Hello everyone, my name is Mr. Amoyavi and I am one of your grade 12 advanced maths teachers. This is the first lesson for term 3 and this term will be all about calculus. Now I know it's a bit difficult for some students but for this topic, but we are going to try make it simpler and you will enjoy learning calculus. All right, so what is calculus? Calculus is basically the word that comes from Latin and it means pebbles, right? Back then they used pebbles or stones to do computations or calculation. Therefore, they named this branch of maths calculus. Right, so what is calculus again? It is basically one of the strands in maths that deal with study of movement or change. Right, so in today's lesson, we are going to start with our topic, average gradient, right? Average gradient. Average gradient of a curve. Now, as you can see, I have two graphs here already. One is a linear graph, as you have learned in grade 11, and the other is a parabola, a curve. Right, so this is how we have defined gradients, right? If given a straight line, we said a gradient can be calculated, which is a constant number. It can be calculated using the formula rise over run. Okay, the gradient will be m is equal to, we say, the rise over run. Basically, it's a change of y, change in y value divided by change in x value. So we can say y2 minus y1 divided by x2 minus x1, which is actually a change in y divided by change in x. Right. So this is how we calculate the gradient. Now the gradient of this straight line will be consistent throughout. Given 2 points, it will be same all the way. Now what I have here in the second graph is here, or diagram, is a curve, which is a quadratic, a graph of a quadratic function. We know this one. Right. If I look at this curve, if I have to calculate the gradient, it won't be consistent. It will not be the same all across every point. And therefore, we will only calculate the average gradient of this curve, y equals x squared, at the average gradient between 2 points, or 2 points on the graph, right? So if I have to take 2 points, points P and Q, and if I have to draw a straight line through the 2 points, then the straight line becomes a secant, what they call secant. The line is called a secant. So we can only calculate the gradient of the secant. That will be also considered as the average gradient of the curve between the 2 points. All right, so if you are to calculate the gradient of this curve using the same formula, right? So the average gradient of this curve will be equal to the gradient of the secant, which is the straight line, right? So we will say it is the, rather, y2 minus y1 divided by x2 minus x1, right? So this is the formula that we can use. It's actually the same formula. So we have a straight line here, therefore we have to use these points to calculate the gradient of this secant, but then that will be also equal to the average gradient of this curve. Right, so let's take a look at one example. For example, if I'm given a curve y equals 2x squared plus 2, and you are asked to calculate, or we are asked to calculate, the gradient between these 2 points. The 2 points, let's say 1 and 4, and the other point will be, let's say, 2 and 10. All right, how am I going to calculate the average gradient of this curve? Right, using this formula, we just simply say the average gradient, which is same as m. We can say average gradient, m will be equal to, y2 will be 10, y1 will be 4, x2 will be 2, and x1 will be 1. And that gives us 10 take away 4 is 6, divided by 2 take away 1 is 1. 6 divided by 1 is 6. Right. So what did we get here? What is 6? This value 6 is actually the gradient of this secant line, or a secant that is going to pass through these 2 points on this curve. Or we can say that is the average gradient of this curve between these 2 points. All right, so basically what we have done is we have introduced the idea of calculus using the average gradient in this lesson. So in our next lesson, we are going to talk about how to differentiate different functions using the first principles method. Thank you, everyone.